back to our channel Electron Chemistry tutorial. I am Vijayalaxmi. In previous video we have done some important objective bits from electrochemistry. So let us discuss remaining bits from the chapter. Before that, let's see some important points from remaining chapter. Okay, let's start. So here galvanic cell. In galvanic cell, chemical energy get converted into electrical energy. Electrical energy means chemical reaction by spontaneous redox reactions, electricity will be produced. Clear? So they are called simply electrochemical cells or galvanic cells or voltaic cells. So in that they are working. So simply galvanic cells contains two half cells, single electrodes connected to each other by salt bridge, external ammeter. Okay, so this is suppose for example zinc electrode placed in ZnSO4 solution, copper electrode placed in copper sulfate solution. Okay, so simply working at anode oxidation takes place, at cathode reduction takes place. Okay, so cell reaction nothing but at anode oxidation nothing but loss of electrons, so at cathode reduction nothing but gaining of electrons. Okay, copper. See here. So cell representation where oxidation takes place, they are written on the left hand side. Parallel lines, usage of salt bridge, it indicates the usage of salt bridge, and copper sulfate by copper. Okay, so this is cell representation. Okay, next EMF of the cell. So E cell, E cathode minus E anode, electrode potential at cathode minus electrode potential at anode, or cathode at right hand side, right side, so ER minus E left. Okay, so then next in this galvanic cell, free energy, Gibbs free energy get converted into electromotive force, means electric current by spontaneous redox reactions. So that's why the relation between the minus delta G by spontaneous reaction, Gibbs free energy always negative, minus delta G NFE cell. Okay, so N means number of electron transfer may be here 2 electrons, so 2 electrons. F means Faraday value, E means electric current, how much electric current produces in that cell. Okay, so simply maybe they are in standard conditions, delta G naught is equal to NF E naught cell. Okay, so the delta G is also equal to the, for equilibrium reactions, minus RT ln K, natural logarithm. So maybe convert into log form, common log. So minus 2.3 RT log K. K means equilibrium constant here. So Nerst equation. So Nerst equation for metal, so by this equation derived by the delta G is equals to delta G naught plus RT ln K. So by this delta G value this one, delta G naught value this one, so RT ln K by deriving will get finally what? E is equals to E naught plus 0.0591 by N log C. For metals or cations, for non-metals here only minus, same formula. Okay, so see here that see nothing but concentration of that electrolyte. Okay, simply galvanic cell, for galvanic cells 2 electrodes are present, no? So that's why E is equals to E naught minus 0.0591 by N log oxidized form by reduced form. Okay, next electrochemical series. How to define? Simply here SRP values means standard reduction potential values. In standard conditions, reduction potentials means amount of energy required for the reduction of that element. Okay, standard reduction potential values. Simply what you get here, I am writing increasing order of standard reduction potential values of electrodes. Okay, simply define electrochemical series. So the arrangement of different electrodes in increasing order of their standard reduction potential values is called simply electrochemical series. Okay, so by increasing value means here suppose for example F2 has more reduction potential value. Which has more reduction potential value means greater reduction potential values, greater standard reduction potential value is a powerful oxidizing agent. oxidizing agent nothing but it oxidizes other elements, other compounds, other ions. Okay, it oxidizes others but reduces itself. Oxidizes nothing but its lost electrons from that elements. So it gains, reduces itself means it gains electrons. Okay, so remember this point. Okay, so greater SRP values as powerful oxidizing agent, so lesser SRP value as what? So reverse, powerful reducing agent. Reducing agent. So lithium is powerful reducing agent means easily can lose its electron, easily oxidize itself and easily gains electrons to the other. Okay, simply which has less SRP value act as powerful reducing agent, which has greater SRP value act as powerful oxidizing agent. So this is, keep in mind, this is important. Okay, so let's do some problems on this formulas. Okay, let's start. Next 13 problem. 12 problems completed before video. So next 13 problem. Given below the half cell reactions, Mn plus 2 electrons gives Mn standard electrode potential minus 1.18 volts. So Mn plus 3 1 electron gives rise to Mn plus 2 standard electrode potential 1.51 volts. Then E naught for the Mn plus 2 to Mn, Mn plus 2 to Mn and Mn plus 3 will be. Okay, so here Mn plus 2 to Mn means gaining up 2 electrons means what? Reduction. So the reduction potential value is how much? That reduction takes place at cathode, no? So that's why this is taken as E cathode. Next here to here. So what happened? Lost one more electron, plus 2 to plus 3, increase in oxidation number, no? So that's why loss of electron means oxidation. Last one electron oxidation, that is simply taken as E cathode here, E anode, that is plus 1.5. So that is nothing but E naught is equals to E cathode minus E anode. So cathode is given as minus 1.18 minus 1.51. How much? Minus 2.69. So see here, E naught values, electromotive force must be positive. So this type of reaction not occurs. Okay. 14th problem. If the standard electrode potential for a cell 2 volts at 300 kelvins, the equilibrium constant of the reaction 300 kelvins approximately for this reaction. So equilibrium constant K we have to calculate here. Okay. So then what he has given? Standard electrode potential has given 2 volts. Next R value is given 8 joules per kelvins per mole inverse. Faraday value is given 96,500 coulombs. Okay. So simply, so what is the relation? So simply delta G is equals to delta G naught is equals to NF E naught cell, no? And delta G also is equals to minus RT ln K, no? So both are so you have to equal. NF E cell is equals to minus RT ln K. Okay. So now minus mutually cancel. N is number of moles of electrons. 2 Faraday value 96,500. So the E naught value is given as 2 is equals to R value 8, temperature 300 kelvins, ln K. ln K is equals to 4 into 96,500 by 8 into 300. Okay, by simplifying this, ln K is equals to 160. Simply k is equals to what? This ln will become e power. So just written as simply. Okay. So this is the answer. Next problem, 15th. In the cell, platinum H2 by HCl, AgCl by Ag. Okay. The cell potential is 0.92 volts. So E is given as electrode potential, cell potential is given as 0.92 volts. Okay. Next, concentration of HCl means H plus ion concentration, that is equals to El minus ion concentration is equals 10 power minus 6. The standard electrode potential, we have to calculate E naught here. Okay. So simply here, for better understanding, you have to write equation H2 plus AgCl gives rise to Ag plus 2Ag plus 2H plus 2Cl minus. Okay. This is the reaction. Okay. So then write down formula. E is equals to E naught minus 0.0591 by n log C means concentration of both H plus Cl minus means H plus ion concentration power 2, Cl minus ion concentration power 2. 2 moles, no, that's why you can take 2 here. So here E is given as 0.92, E naught minus 0.0591, simply you can take in as 0.06 by n. How many number of electrons are transferred here? So here Ag plus but 2 moles, so here 0, but here 2 plus 2 Cl minus nothing but simply here to here 2 into 1 electron, 2 electrons. So here to here also 2 electrons, simply 2 electrons. So 2 n is equals taken as 2 electrons. Okay. Log concentration of H plus, how much? 10 power 6 molar solution means 10 power 6 power 2, 10 power again 6 power 2. Okay. Then simply here 0.92 is equals to E naught 0.03, so into log 10 6 2s 12 means 10 power 24 minus 24. Okay. So then simply 0.92 is equals to E naught minus 0.03 into minus 24 log to the base 10. So log to the base 10 nothing but 1. Okay, this is equals to 1. By calculating these two, so we'll get 0.20 volts. Clear? Next problem. Given the equilibrium constant Kc of a reaction Cu plus 2Ag plus Cu plus 2Ag plus gives rise to Cu plus 2 plus 2Ag is equilibrium constant is 10 into 10 power 15. Calculate the E naught at 298 kelvins. Simply at equilibrium, simply E naught is equals to 0.0591 by n log Kc only. Enough. Okay. Simply 0.0591 nothing but approximately you can take 0.06. N means how many electrons take? So 2 electrons here. So Cu 0 plus 2 increases plus 2 0 means how many electrons transfer here to here. So in redox reaction 2 electrons are involved. So you can take 2 electrons here. Log C 10 into 10 power 15 means you can take simply 10 power 16. Okay, so 1 is 0.03, then 0.03 16 into log 10. Log 10 always 1, no? So then how much? 0.48 volts. Okay, next, for the equilibrium 2H2O gives rise to 2H3O plus OH minus, and the value of delta G at 298 kelvins is approximately. So delta G we have to calculate. So it didn't give anything, but we have to calculate delta G value. So I will show you. See here, delta G, G naught is equals to minus 2.303 RT log K. Okay, so this is what equilibrium reaction for water means. Simply you can take ionic product of water, that is K. So we know very well that value is at room temperature 10 power minus 14. Okay, so then simply here minus 2.303, R value we know very well 8.314 joules. Okay, so then joules per Kelvin for mole inverse. So then T is given as 298 kelvins log 10 power minus 14. Okay, minus 2.303 8.314 into 298 minus 14 log 10. Log 10 value is 1. Okay, so by multiplying this value 0.0789 joules, but he asked in kilojoules. So then simply kilojoules means into 10 cube. Okay, means 78.9. So that is approximately 80 kilojoules. Okay, clear? Next problem, the standard Gibbs energy for the given cell reaction in kilojoules. At 298 Kelvin is Zn gives rise to Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. E naught is given. So we have to calculate delta G naught value. So E naught is given. What is the relation between them? So NFE cell. Okay. So how many electron transfer here? Here to here 2 electrons. Here to here also 2 electrons. So number of transferred electrons to Faraday value we know very well, 96,500 coulombs. E naught is given as 2 volts. By multiplying we will get 384 kilojoules. Clear? Next problem. Here given cobalt plus 3 takes 2 electrons. So cobalt plus 2 means reduction to give. So this reduction potential value 1.81 volts. So this is also reduction potential. So what is that? Plus 1.67. So this is also reduction reaction. So this is in a reduction potential value 1.61 volts. So this is also reduction. This is reduction potential value, standard reduction potential. These all are what? Standard reduction potentials. Standard reduction potentials. Okay. So oxidizing power of this species will increasing order. Okay. Simply as increasing standard reduction potentials, oxidizing power also increases. Okay. Simply increasing order, nothing but simply here. So which has lower reduction potential value? This one 0.20 volts, less than that of 1.61, less than that of 1.67, less than that of 1.81. So 1.61 has what? Bismuth. Okay, less than that of cerium, less than that of lead, plumbum, less than that of cobalt. So this is what? Increasing order of their oxidizing powers. So oxidizing powers increases with increasing their standard reduction potential values. Clear? The incorrect match in the following. See here, delta G so versus K simply. So what is the relation between them? So delta G negative delta G naught is equals to RT ln K. Okay. So means for spontaneous reactions, delta G is always negative, K is equilibrium constant positive. For equilibrium reactions, delta G 0, delta K is 0 or positive. For non-spontaneous opposite, delta G naught is positive, K is negative. So simply opposite simply. So here delta G is positive, this is negative. Okay, this is correct. So delta G 0, this is positive. Okay. So this is negative, this is positive, this is also okay. But both are almost less than 1 means negative signs. Okay. So this is not possible. So both are in same signs are not possible. They are opposite. Okay. So that is incorrect match. Okay. So this one, the decreasing order of electric conductivity of the following. So which is given 0.1 m formic acid. So that is A. 0.1 m acetic acid, B. So 0.1 m benzoic acid. All concentrations are same. All are acid simply. Okay. So for A means what? Formic acid, HC double bond OH. Next B means acetic acid, C double bond OH. C means benzoic acid. Okay. So all concentrations are same, nothing but, so you can take dissociation constant, acid dissociation constant. Simply electric conductivity depends on acid dissociation constant. Okay. So here acid dissociation constant for formic acid is more than that of the benzoic acid more than that of the acetic acid. Okay. Simply formic acid A greater than C greater than what? B. So this is the relation. Clear? Next, for the reaction Fe, 2Fe plus 3 plus 2 minus I minus gives rise to 2Fe plus 2 plus I 2. The magnitude of the standard molar free energy change delta G minus in kilojoules. Okay. So standard Fe plus 2 by Fe is given as 0.440 volts. Fe plus 3 by Fe 0.036 volts. I is given as. Simply here delta G. For calculation of delta G naught is equals to minus NF E naught cell. But for E naught cell is nothing but, so what is that? Simply E cathode minus E anode we have to take here. So E cathode nothing but what? So reduction. So Fe plus 3 by Fe plus 2 minus I minus by I2. Okay. So but E naught direct Fe plus 3 by Fe is not given. Fe plus 3 by Fe plus 2 is not given here. So we have to calculate this. E naught of Fe plus 3 by Fe. For this, so we have to take Fe plus 3 to Fe minus Fe plus 2 to Fe. So simply here, how many electrons are transferred here to here? 3 electrons are difference. Okay. So simply 3 into Fe plus, simply here 3 into E naught Fe plus 3 by Fe minus, here how many electrons are changed? 2. So 2 into E Fe plus 2 by Fe. Simply what is this value? 3 into minus 3, 0.036 minus 2 into minus of minus 0.440. Okay. So by simplifying this, we'll get 0.772 volts. Okay. So this is calculated. This is already present here. So calculate that. E cell, E naught cell, standard electrode potential of that cell, E cathode minus E anode. Cathode is calculated as 0.772 minus, so I value, electrode potential of iodine 0.539. Okay, 0.233 volts. Now here E naught calculated. Now delta G naught minus how many electrons? 2 into, so charges difference in 1 only but 2 moles. So 2 into 1 2. So here 2 minus I2. So 2. Here 2 electrons are difference. Here also 2 electrons are difference. So simply you can take here 2 into Faraday value 96,500 coulombs, we know very well. Then E naught value 0.233 volts. Then simplifying we will get answer. Clear? Next problem. In the galvanic cell, Zn by Zn plus 2 concentration C1, Cu plus 2 by Ce concentration C2. E cell minus E naught is equals 0.0591. The value of C1 by C2 at 298 kelvins. It's very simple. See here, E cell is equals to E naught. Nernst equation for galvanic cell, write down first. 0.0591 by N log C1. So oxidized form by reduced form, no, C1 by C2. Okay. Next, here, so this E naught takes here, E cell minus E naught, that is equals to minus 0.0591 by N log C1 by C2. Okay. So this value is given as how much? 0.0591. So that is how many electrons are transferred here? Simply here Zn gives rise to Zn plus 2 and Cu plus 2 gives rise to Cu. How many electrons are transferred here? 2 electrons. Okay. So simply 0.0591 by 2 log C1 by C2. This value star takes to here 2 by 0.0591 log C1 by C2. 0.591, 0.0591 mutually cancel, then here 2. Okay. So 2 is equals to log C1 by C2. So simply this 2 is written as log 10 square is equals to log C1 by C2. Got it? So log 10 square nothing but 2 only. How to get? Simply here log 10 square nothing but 2 log 10, no? Log 10 value is 1, no? 2 into 1, 2 only. Okay. Clear? So simply, so instead of 2 I am writing log 10 square. Okay. Clear? Now log mutually cancel, then what is the ratio? C1 by C2 is equals to 10 square. Clear? So this is answer. That's all, friends. So if you have any queries in the chapter, so please put a message in the chat box. Okay. So thank you for watching this video. Thanks a lot.